Princeton myself, and I have given a talk about this part too in various other places, and several other universities have started to do this. I was in Freiburg, and there they have also an Institute for Advanced Study. There are now many institutes trying to do something interdisciplinary in one way or another, and they started to do it, and they also liked it. Once you think about it, it's very natural. But if you don't, if you have this picture in your mind, then there is no room for after-hour conversations. Then you think if you drink alcohol, that is your own thing, that is nothing to do with work, that is just your own hobby. You should pay for it, as you said. But once you really realize the true nature of interdisciplinary communication, in your own field, as a student, you go to a party. So if you do interdisciplinary work, you have to learn a new field. So you have to be like a student again. You have to be at parties together. It's the only the only way to really work, I think. So this is what I did in my own institute in Princeton. But I also did something else, which I started about 13 years ago. And that is called the Kira Institute. And it comes from the Japanese kira kira. We think it was a brilliant idea to start an interdisciplinary Kira Institute. And this is not an institute which exists somewhere. It was just a few people, one professor from Stanford, a psychologist, cognitive psychologist, one from Princeton University, a philosopher, me from Princeton Institute for Advanced Study, another physicist, various people coming together. And we talked about science in context, science and other ways of knowing, science and art, science and various traditional forms of knowledge. And we had a number of workshops. We did that for 8 years, quite a few weekend workshops with a few people. And also, it was for our own research, but also for the education, we had a number of summer schools, 2 weeks, in which we got 25 students together from very different fields of science to talk. And when we got the students together, we did not have to teach. When the students talked to each other, we brought the students in one room and we asked them, what is science? And each student said something very different, gave a very different answer. And they looked at each other and they were very surprised. How come they gave such different answers? And then they started quarreling with each other in a friendly way. So there was very little we had to do because they could educate each other in a fun atmosphere of these summer schools. Actually, here's an example of the type of discussion we had. Not like in a classroom, but like in a very informal way. This was in the year 2000. There were also some Japanese students, as you can see here, in the evening sessions. So we have a website about the Kira Institute. And one thing which we recently started doing is to use virtual worlds. Virtual, three-dimensional online worlds like Second Life. It's very different from video conference. In a video conference, there is a camera and you have to stay in a certain space. And everybody is like sitting in their own cage. And you cannot move and you cannot go to the other. But in a virtual world, everybody gets an avatar, a character, and the characters can really meet, and they can mingle, and they can do fun things, build things together, have fun, making yourself into a very different type of animal or whatever. So the fun element is much more pleasant in virtual worlds like Second Life than it is in video conferencing. Here on the website, you don't have to read all of this, but the 3 things which are important, we think, in a very broadly interdisciplinary group like the Kira Institute, is pluralism, that you have many different points of view. Critical thinking, you have to be critical, since if you're just putting things together, then there is no meaning. You have to also really test, but the question is in what way. And then this playfulness that I've been talking about. So here is Second Life. How many people have heard of Second Life? Kita Kodogaru desu ka, second life. Yeah, about half, almost half. In America too, half the people have heard of it when I give a talk and half have not heard. It is not very popular yet. I thought it would become more popular, but it seemed very logical. In the 1980s you have email. Email is one-dimensional. In the 1990s you have a website. Website is two-dimensional. And in the 2000s they had virtual worlds, three-dimensional, playful environment. But somehow it hasn't caught on. Maybe it is too much work to learn it. Maybe it looks like a video game. Like going out to drink doesn't seem serious. And going in a three-dimensional world looks like a video game. It doesn't have the feeling of academic serious. But in our experience, it really worked for interdisciplinary communications. So this is what we started to do a couple of years ago. And what we had is that in Second Life, we made a virtual branch of the Kira Institute. So we built a campus and a cafe, again, to have, not a classroom, but a cafe, to have the informal sense of meeting each other. And also we are doing science experiments. So here is one of the science experiments. Doesn't come out very well here, but here, it's a pity. The saturation is much more here than on my screen. There is an avatar here playing with stars. And the avatar creates stars, and the stars interact with Newtonian interactions. So normally in the virtual world, if I drop something, it falls. But falling is just one line in the computer program for virtual worlds. If you change the falling, and if you go not in not a constant force field down, but if you have the two-body interaction of Newton, 1/r², then if you drop something, things fall around each other. So if you take a virtual world and you change only a few lines, you have an astrophysical simulation and visualization all for free. So that shows how flexible a virtual world is. You can not only meet each other, you can also do experiments. It was a lot of fun, and we are still continuing to work on that. So this is basically what we are doing in Second Life. And OpenSim is an open source version of Second Life. We cannot change the gravity in Second Life because our neighbors would be very unhappy if suddenly if they drink tea and tea goes in orbit. So we have to go to our own version of virtual reality called OpenSim, open source version of simulations. And therefore, what we have been doing here is that we are focusing on education as well as research. And our research here is for some part in Second Life, but mostly in OpenSim. Actually, Second Life is a whole world by itself. There is a newspaper in Second Life, several newspapers, and one day I got in there and they wrote up about what I had been doing with astrophysics experiment, as I showed. I look a little bit more QVC in my avatar. And also, I have longer hair in Second Life. It's more like when I was a student. So interestingly, we applied for a grant, a relatively small grant proposal a couple of years ago, and that was also a nice example of an interdisciplinary collaboration between the Kokuritsu Hogaku Kenkyūjo in Tokyo and Kokuritsu Mumbai also in Tokyo. So it's these two different institutions which normally don't collaborate much, but thanks to the virtual worlds, we could collaborate with the two of them to get them to work together on these simulations. So this is again the same conclusion which I put up earlier. So this is the part of the talk which I prepared PowerPoint for. And maybe I can spend a few minutes writing something on the blackboard about an even broader type of research that I have been involved in. Maybe,
sure.
Shall I just... Well, yeah, I don't know, are there any, maybe if there are particular questions about anything I showed so far, I should keep the computer on.
I don't know, so like we asked for
Shall we
questions
just,
for that, or?
yeah, or shall I just go, maybe I should just finish and
Yeah, that'd be
throw
great.
something on the blackboard. I will close this then.
Yeah, me too. Chokes, right?
Yeah.
Ah, over there.
Ah, yes, I see. The colors. So, of all the different interdisciplinary things which I've been working on, the thing that I do most often is the collaboration between astrophysics and computer science. Because in astrophysics, or as they call it in Europe and in Japan too, informatics, Yohogaku. It's a much better word. I mean, mathematics is not pencil science. Mathematics is mathematics. And computer science is informatics. They work with information. They happen to use computers. So between astrophysics and informatics, the collaborations are often somewhat difficult because if an astronomer writes a computer program, they have a very small base and they write something that works, and then something more complicated, and something more complicated, and something more complicated. And this is what a typical astrophysics computer program looks. It's a tower which sooner or later starts falling over, and it doesn't work anymore. If a computer scientist writes a program, and we ask, please help us, then the computer scientist says, no, you have to have a very broad base. You have to think in a very systematic way, and you have to put everything in there, so then you can build something on top. And you can build this, and you can build that, and you can build this. And then suddenly it is 3 years later, and you have no time. Your money runs out, and you have to get a PhD. So astronomers write programs which are like this. And if they ask for help from computer scientists to get this, and of course what you really need is something in between. I mean, this would be the ideal computer program. That you have a broad base, and then you have more and more detailed versions, and then you have something which has the same functionality as the applications in astrophysics, and it has a similar base for computer scientists, and it can be modified. Or ideally, if there's really a big problem, situation, a whole class of problems, you would like to build an environment, and on the environment you can have building blocks in which you can build different things and maybe different applications on one, and you can build like a castle with different towers and stuff. So the astrophysical castles are much too narrow, and most of the computational science castles are much too flat, at least for us. I mean, if your interest is research in computer language, this is the right thing. But if your interest is in application, you need to balance breadth and width. So what is needed as a collaboration is computational science. Not computer science or informatics, but computational science. Science in which you can